Hopefully you had some success putting our queue from stack problem together. Now, in tackling this problem, you're going to very quickly realize that it's just another one of these problems where as soon as you see the solution, you say, oh, okay, yeah, makes sense. I'm ready to do this now. So rather than trying to be clever and very gracefully explaining the solution here, we're going to take a look at a diagram that's going to very directly show you exactly how to address this problem. And then once you see that, I think that a light bulb might click and you'll say, oh, okay, yeah, that makes sense. So let's take a look at a couple diagrams that are going to help us understand exactly how to approach this. Okay, so remember, we are working with two stacks here. So I have labeled stack A and stack B. Stack A and stack B follows the rule of stacks, right? Well, of course that makes sense. But the rule of a stack is that the first record in is the last record out. That's not the behavior we want here. We don't want stacks, we want to make a queue. And the common characteristic of a queue is first in, first out. So that's what we really want to do here. We can forget the terminology of stacks and queues. All we really want to do is think of how we can use these two things right here to make a first in, first out principle. So let's figure this out. The first method we're going to discuss is add. So we're going to first figure out how to implement the add method. So for the add method, whenever we add a record, we're going to take that record and add it directly to stack A. We're going to pretend like stack B does not even exist. So we're just going to take this green record here. Let's say we want to add it to our overall queue structure. So we will add it to stack A, right? Then we want to add in, say, record blue. We'll take blue and we'll add it in to stack A. And then for red, we'll add it in to stack A. Now remember, if we called pop directly on stack A, the records that we got out would be the reverse of what we actually want. So if we called pop on stack A, we would get back red. That is a first in, last out methodology. And that is, again, not what we want to solve this problem. We want first in, first out. So at this point, if we called remove or pop or whatever on our kind of synthetic data structure here, my expectation would be to get out green. So we need to figure out some way of getting green out of this thing. But remember, with the stack, we don't have any way of reaching directly to this item at the very bottom of the stack. We need to somehow figure out a way to get at this record green right here with only the ability to remove or add records from the very top of the stack. So let's look at a diagram to explain the remove method, and we're going to figure out exactly how that's going to happen. So again, let's assume that we added in green, blue, and red to stack A, and now we want to somehow get access to record green right here, because if we were to remove from this thing, we should be getting back green because we want to follow this first in, first out methodology. So here's what we're going to do. This is like, all this talking I'm doing, it all comes down to this. Here's what we're going to do. When we want to get our record out of here, we're going to pop records out of stack A one at a time. For every record that we pop from stack A, we are going to push it into stack B. So I will pop from A, that removes it. I will then take that record and push it into stack B. And so it goes down here to the very bottom of stack B. I will then iterate through all the remaining records here. And when I say iterate, keep in mind that we can't iterate directly through a queue. We have to look at or use our peek method to see if there are any records left that we can manipulate. So we will peek at the next record. We will see, yep, something's there. It's blue. We will then pop it out. We will push it into stack B. We will then peek at stack A again. We will pop it out. We will push it into stack B. We will then peek at stack A one last time. And when we peek this last time, we realize, oh, okay, there's no other records here. Stack A is now empty. So at that point, we will then say the record that we actually want here must be the next record that is going to come out of stack B. So all we have to do is pop from stack B one time, and there's the record that we want to actually return from our data structure, from our queue data structure, from this kind of synthetic remove method that we are creating. So essentially move everything from A over to B, pop from B one time, and there's our record. Now before we just return this record right here, there's one more thing we have to do. We need to make sure that we restore everything back into stack A to get ready for our next operation. Because who knows, it might be a remove operation again, in which case we will want to move everything over to stack B again. So before we return green, we will call peek on B. We'll say, is there anything here? If there is, we'll pop it out, push it into A. We'll call peek on B again. If there's anything there, we'll pop it out, push it into A. We'll call peek on B again. We'll realize there's nothing else here. And so we're all done. We're ready to now return from the remove method. So that's pretty much it. That's the whole shebang. Now with that in mind, I bet you can kind of guess how the peek method gets put together. So peek here, we're doing essentially the exact same thing. The only difference is that this time, when everything moves over to stack B, we are not going to pop green out of there. We are only going to peek out of stack B. So we can assume here, we'll go through this very quickly. If we add in A, blue, or excuse me, green, blue, red, we'll then pop red over, pop blue over, pop green over. Stack A is now empty, so there's nothing else for us here to do. That means we can call peek on B. We can peek it. That will peek the first record here, so that's green. And then once we've peeked it, we can then pop everything out of B one at a time and push it back over to A, like so. Now, if this sounds like it's amazingly inefficient, the answer is yes. Yeah, of course it's very inefficient, but it's an interview question. It's just made to help you understand, or to show, I should say, that you understand how queues and stacks work. That's the whole idea here. Of course, you're totally correct. We would never implement this data structure in the real world, but as we've seen, there are many types of interview problems that we end up having to do that have absolutely no real world implication whatsoever. So anyways, that's a totally separate discussion. Okay, I think that we've got a better idea of how to put this solution together. So let's take a quick break right now. We'll continue in the next section and start working through a written solution to this queue from stack problem. So quick break, and I'll see you in just a minute.